Hi, Integrated Math 1. Welcome to your review. So this is a video to help you walk through the study guide for your test, for your Unit 2.4 test, Shapes on the Coordinate Plane. So this is the Unit 2.4 study guide. And I really recommend that you try these problems out on your own first and then watch the video. But you know how this goes. These problems are just like the ones on your test. So if you want to know what you're up against, this is what you're up against. So I'm just going to walk you through each of these problems. So we're starting off with number 1. We have a quadrilateral here, quadrilateral JKLM. And we're asked to do a few things. First, it says to determine the slope of each line segment. No problem. Rise over run, right? Rise over run. So let's just find each one. Let's start with JK. Just kidding. Let's start with JK. So slope of JK. So to get from J to K, it looks like I got to go down. 1, 2, 3, 4, 5, 6 units down. So that's my rise. That's a -6. And then my run, 1, 2, 3, 4, 5, 6, is 6. Of course, that does simplify down. Always simplify whenever you can. -6 divided by 6 is, of course, a -1. And there you go. Let's do another one. I'll grab another color here to help change it up a bit. And let's do the slope of LK. Again, rise over run. So it looks like I do go up this time. 1, 2, 3, 4, 5, 6 units up. That's my rise. And then I go to the right. 1, 2, 3, 4, 5. So it looks like my run is 5. So I went up 6 over 5. Great. I've got 2 more sides. We've got to find the slopes of all of them. So let's do ML. So slope of ML. To get from M to L, I do have to go down. Ooh, and it's a lot. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh, I dropped like 8 units. Holy crud. So there's my rise and my run. 1, 2, 3, 4, 5, 6, 7, 8. Great. So I have a run of 8. Oh, which simplifies as well. -8 over 8 is, of course, -1. Hey, those are the same. I feel like that should tell us something. We'll talk in a minute. One more slope, and I'll pull out the lovely purple. Slope of MJ. I'm not even Spider-Man, but I still like the sound of that. Slope of MJ. So it looks like I have to go up this time. 1, 2, 3, 4 up. Over my run, which is 1, 2, 3, 4, 5, 6, 7. I have a run of 7. That does not simplify. So can we just take a minute, before I get to question B, I do want to take a minute and notice a few things. First of all, I see 2 slopes that are the same. And that tells me I have 2 lines that are parallel. That tells me that ML is parallel to JK. But notice these other slopes are not the same. So these sides are not parallel. So I have one set of parallel sides. So I have slope, 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 slope. I don't see anything perpendicular. Now remember to be perpendicular, so your slopes have to be opposite reciprocals, right? That was the deal, that it had one's positive, one's negative. If one's 6 over 5, the other should be 5 over 6. I don't see that happening. So I don't see any perpendicular sides. I just see one set of parallel sides, no right angles at all. So part B, determine if quadrilateral JKLM can best be described as a trapezoid, a rhombus, a rectangle, or a square. Guys, if I have one set of parallel sides, as I plunged into darkness, that is a trapezoid. And there it is. Yay. Wow, it is dark. You guys can't see me at all. It's better now. There we go. So this is a trapezoid. I found all my slopes. I have one set of parallel sides. A trapezoid it shall be. Let's go to problem number 2. Analyze triangle X, Y, Z. If it's not obvious, there is a side here. Sorry if it's not terribly obvious on your paper. We want to determine if our triangle is scalene, isosceles, or equilateral. Well, that depends on how many sides are equal, right? Do I have no equal sides, 2 equal sides, 3 equal sides? So this sounds like a job for the distance formula. Yep. So I need to do some distance formula. That's fine. I can do that. Let's take them one at a time. Let's start with xy, because that's easy. I don't need distance formula, right? I can find the length of xy. xy. I can just count that one because it's vertical. Slanted sides, we have to do distance formula, but if it's vertical or horizontal, I can just count it. So I will. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, great. That's 10. Hooray. Let's find xz next. So we'll do xz. I do need some coordinates. If I'm going to use distance formula, I need some coordinates. So it looks like x is at -4, 8. So -4, 8. And it looks like y is at 2, 0. And so I have x, I have y, I have x, I have y. Let's do some distance formula. I'll subtract my x's. -4 minus 2. Pew, pew, pew. I will subtract my y's. 8 minus 0. Pew. And we'll do the square root. So -4 minus 2 is, of course, -6. 8 minus 0 is, of course, 8. And we'll do the square root. -6 squared, a negative squared does become a positive. 8 squared is 64. If I add those together, 36 plus 64, and yes, use a calculator. Heaven help us all, use your calculator. If I add those together, I do get 100. Oh, I know what the square root of 100 is. That's 10. So the square root of 100 is 10. Oh, so this side is 10 and this side is 10. Interesting. Let's find our last side. See if that last side is also equal. So let's find side YZ. I have the coordinates for Z. Let me write down the coordinates for Y. It looks like they're at -4, -2. Awesome. So we'll do -4, subtract our x's, -4 minus 2. That looks familiar. We'll subtract our y's, -2 minus 0. And do a big square root over it. -4 minus 2 is, of course, -6. Like I said, we did that before. -2 minus 0 is -2. And when we square negatives, they become positives. So this becomes 36. This becomes 4. And so I have the square root of 40. And if I use my calculator, the square root of 40 is like 6.3-ish, which is definitely not 10. All right, so it looks like I have 2 equal sides. So that means, since I have 2 equal sides, I am dealing with an isosceles triangle. This is what we mean by show your work. You've got to do distance formula for all 3 sides. You have to do distance formula for all 3 sides. There's no way around it. There is a second question down here. My camera's in the way. Hang on. My face is in the way. There is a little bit more. Describe triangle XYZ as acute, obtuse, or right. Also show your work. All right. I hope you have this written down because I'm about to erase it so I can do the work for the next part, okay? So I'm going to erase this. I want my eraser. Erase it. I don't want to erase what I wrote on my triangle because I actually want those numbers and I don't want to like lose them. Erasing. Not the most exciting part of the video, I suppose. Ooh. Sorry, I'm fussy. I like to get rid of all the bits. All right, now I did leave my numbers up here because I am going to use them. So remember, you can determine if it's acute, obtuse, or right with the one, the only Pythagorean theorem. Oopsie, just kidding. Hang on, guys. I'll bring it back, I promise. I accidentally closed it. There, that's better. I'll try again. Pythagorean theorem. This is the fun of these videos. You get to see all my weird moments. So remember the deal, a squared plus b squared equals c squared, only if it's a right triangle. If your c squared is too big, it's obtuse. If your c squared is too small, it's acute. Now, c is our longest side. I have two longest sides. I have a 10. So we're going to do c squared. I don't know if it's equal to a squared plus b squared. That's what we're trying to find out. So one of the 10s will have to be my c squared, and then the other 10 and the 6.3 will be my a squared plus b squared. Use a calculator, it's helpful. 10 squared is, of course, 100. That happens over here as well. Just have a question mark in the middle till I know what's going on. If you square this, you should end up back about 40, right? Because it was the square root of 40 that gave us 6.3. So if we square it, again, we end up back at 40. At least we should, theoretically, hopefully. Yeah, and 100 plus 40 is 140. That's too small. It's too small. 100 is too small. So because my c squared is too small, right? My c squared is way too small. This must be an acute triangle. Yay! Number 3. Oh, this is one of the nicer ones. Do you remember how we did this? We've done this a few times in class now. It's a really good trick. I want to determine point D such that quadrilateral ABCD is a square. So I need to figure out the coordinates for point D to turn this into a square. I only have like part of my square right now. But you know squares and how they work. All of the sides are the same, aren't they? And the opposite side should be parallel, right? So whatever one side is doing, the other side must be doing the same thing. So I'm going to do my rise over run from B to A. So to get from B to A, I have to rise 1, 2, 3, 4, 5, 6. So I had to rise 6, and then I have to run 1, 2. So I have to go up 6, over 2. So from C, I'm going to have to go up 6 over 2. So up 6, 1, 2, 3, 4, 5, 6, and over 2, 1, 2. Boom! There it is. There's point D. The coordinates for point D, I do need to give the coordinates. So D is at, where do we go? Right 7, up 4. Yeah. And I can connect it and like make my square. And isn't it a pretty little square? Woo! I feel like that was nicer than some of the other problems we've done. Number 4. Analyze rectangle BHQY. Determine the perimeter of the rectangle. Okay, I know that perimeter is double the length plus double the width. I need the length and the width. Okay, I need the length and the width. Okay, I can do this. Please be careful when writing down your coordinates on this one. We will need to use some distance formula to get my length and to get my width. Please be careful with the coordinates. Please note, we are counting by 2's on the x-axis. Please notice. So I'm going to start by finding BH. If I start by finding BH, it looks like B is at negative, again, for counting by 2, 16. So it's negative 18 and up 4. And it looks like H is at negative 12 up 8. So I'll subtract my x's. Negative 18 minus a negative 12. Watch the double negatives. Subtract my y's. 4 minus 8. You're welcome to use a calculator, but also hopefully remember double negative becomes a positive. This is actually negative 18 plus 12, which is, of course, a negative 6. 4 minus 8 is negative 4. Negative 6 squared is 36. Negative 4 squared is 16. Together, I believe that's 52, but I'm going to double check. I'm going to use my calculator and double check because I make mistakes. Yeah, it's 52. 52. And the square root of 52, again, thank you, Mr. Calculator, because I'm not doing that in my head, is about 7.2. So I found my width. That's great. My width is 7.2. I need my length. So I'm going to go ahead and keep using H, but I'm going to go for Q. It looks like Q, where are you, Q? So Q is at -4, -4. All right, doable. So I will, to find HQ, headquarters, I need to do this. -12 minus a -4. Sorry, my handwriting's getting tiny. You know what? I'm not going to write it there. There's just not enough space. I thought I had enough space. I don't. I'm going to write it over here. So for HQ, I'm going to do -12 minus my -4 and square it. I'm going to do 8 minus a -4 and square it. Big square root. Double negative becomes a positive, so -12 plus 4 is a -8. Double negative becomes a positive. 8 plus 4 is 12. 8 squared is 64. 12 squared is, that is a 4. Sorry, 12 squared is 144. And if I add those, 64 plus 144. Solar calculators in the dark are a little rough, but I get 208. Oh dear, 208. And if I do the square root, it's about 14.4. Sorry for the weird pen. All right, so hang on, I'm gonna grab another color just to help distinguish here. So we found that my width was 7.2, my length is 14.4. Fine, if I wanna find the perimeter, I'm gonna double my length, I'm gonna double my width, double my width, double my length, either way, and I'm gonna add those together. So if I do 7.2 times 2, I do get, I can do this, wow, 7.2 times 2. My calculator's being weird in the dark. I get 14.4, oh, funny that. Plus, if I double 14.4, I get 28.8. And that means, if I add those together, there it is, 43.2, roughly. We did round earlier, so this might be a tiny bit off, but you get the idea. You know what the best part is? Now that you've done all the wicked nasty stuff, you can do this last one. Determine the area of a rectangle. Well, the area of a rectangle is length times width, base times height, whichever you prefer to use. So fine, I'm gonna do, for my area, we'll do 7.2 times 14.4. And we will use our calculator to make that happen. 7.2 times 14.4. And we got like 103.68. That's about what I got. It does say to round to the nearest 10, so we'll say 103.7. And again, it's probably a little bit off because we did round earlier, and so that's gonna, make it a little bit off at the end. I think the exact answer is actually 104, but that's something for another time. Number 5, we're asked to determine the area of our right triangle. Now, you don't have, it's not on my screen, but you have written on your lovely little guy, you see, that's a right angle. All right, so this is a right triangle. We want to determine the area. We know the area is 1/2 base times height. You multiply your base and your height, you cut it in half. That means we need to use distance formula to find our base and our height. So much distance formula. I can't help it. It's a key standard in integrated math 1 is finding areas and perimeters using distance formula. So I'm sorry. Let's go ahead and do this then. It looks like we went left 3, so that's a -3. Yeah, look how they're counting. -3 up 3. Wow, watch out. L is at 2, 4. Yeah, look at those axes. Watch how you're counting. So for side ML, we'll do some distance formula. -3 minus 2, subtract our x's. Plus 3 minus 4, subtract our y's. So that means -3 minus 2 is -5. 3 minus 4 is -1. -5 squared is 25. -1 squared is 1. So it's the square root of 26. And if I use my lovely calculator, I get about 5.1-ish, nearest 10th, right, and all that. So about, whoa, my pen, come back, about 5.1. Sometimes that pen has a mind of its own. I don't know what to tell you. Oh, I found my base is 5.1. I need my height because remember, height is perpendicular to the base. So I need my height. Well, I have the coordinates for L. See the coordinates for N. Right 3, down 1. So 3, -1. 3, -1. Great. All right. So ln. Let's subtract our x's. 2 minus 3. Subtract our y's, 4 minus a -1. 2 minus 3 is -1. 4 minus a -1 is 5. -1 squared is 1. 5 squared is 25. Wait a minute, this looks familiar. 1 plus 25 is 26, and I already know the square root of 26 is 5.1. I've done this one before. So let's find the area. 1/2 base times height. All right, let me come back to my other color here. So let's find the area. 1/2. We found the base was 5.1 and the height was 5.1. So I guess 5.1 times 5.1. Sorry for the bad writing. And I will use my calculator if it will work. It's getting dark in here. Hang on. I'm going to turn the lights on. Maybe. We have light. Huzzah, happy day. All right. 5.1 times 5.1. And don't forget to divide by 2. And I got like 13.005. So I'm just going to round that to 13. If you really want to put 13.0, that's probably a good idea, a good plan. Lovely. All right, all right. Last one. You've made it this far. Made it this far. Number 6. Last one. Last one. Determine the area of the composite figure round to the nearest 10th. Thank goodness it's asking for area, not perimeter, because I can get away with not using distance formula. True story. So we said for a composite figure, you want to chop it up into rectangles and triangles, right? Because I know how to find the area of rectangles and triangles. I can do that, right? So I'm going to chop off this rectangle. So I have this lovely rectangle here, right? Here's a lovely rectangle. And it looks like, again, we're counting by 2s. Please be careful. We're counting by 2s. So 2, if I count my base here, my length and my width, 2, 4, 6, 8, 10. It looks like that has a length of 10 here. And then 2, 4. So for the area, for this first one, it looks like I'm going to have to do 4 times 10, length times width, which gives me 40. I'm going to pick another color out here. I'm going to cut off this little triangle here, right? As you see, I can cut off a triangle and I make like a nice triangle. We know triangles are 1/2 base times height. So let's see. It looks like my base is 2, 4, 6. It looks like my height is 2, 4, 6. Okay. So base height. 6 times 6 is 36. If I divide that by 2, I get 18. Let's cut off some more triangles. I'm going to cut off this triangle. Oh, it's like an itty bitty baby triangle. Look at me, so little and cute. So it looks like my base is 2, 4, 6 units. Looks like my height is 2. So area equals 1/2 base times height. 6 times 2 is 12. Divide that by 2 and you're back down to 6. Let's cut off another triangle. I'm going to use the purple one. I'm going to cut off this triangle. Oh, yeah, there we go. Cut that guy off. It's not nice to do that in traffic, but apparently it works here. My base is 2, 4, 6. My height is 2, 4. So the area is triangles, 1/2 base times height. 6 times 4 is 24. Cut it in half, you have 12. One more. I have a big old rectangle here. Did you lose it? Don't lose it. I have a big old rectangle here. Here's my big old rectangle. I already know the width of that thing is 6. Let's just find the length of it. 2, 4, 6, 8, 10. Area of a rectangle is just length times width. So we'll just do 6 times 10, which is 60. Now, I want the area of the composite figure. I want all of the areas together. So I'm going to add them all up. I'm going to add them all up. I'm going to do 40 plus 18 plus 6 plus 12 plus 60. Did I get them all? 1, 2, 3, 4, 5. 2, 3, 4, 5. Okay, making sure I got everybody. And I'm just going to use my calculator. 40 plus 18 plus 6 plus 12 plus 60. Look at that, guys. I have 136. Oh, that's the area of the whole figure. Rock on. We're good. We're good. Hope you found this helpful and useful, guys. Again, these are the kinds of problems you're about to encounter on your Unit 2.4 test, Shapes in the Coordinate Plane. Make sure you study. Make sure you know how to do these. You're welcome to go back and watch this video as many times as you need to. And I'll see you guys soon. Bye.